Explain everything. The Explain Everything app is pretty great in the idea that you can do what a lot of other presenting tools do, but you can do more of them all at once. For instance, the same capabilities as a PowerPoint in the idea that you can have multiple slides and that you're in control of when those slides change and how they change. It's similar to a Prezi in the idea that you can have a ginormous screen and you can have multiple things splattered on it and then bring them up as you would like them to be viewed. You can also animate some things like a Glogster. So if I want to draw your attention to the word Glogster, I could continually circle it with my laser pointer. And then the obvious thing, as you've probably noticed, is you can record like an iMovie. So you can do all of these different things all on this one app, which makes it really easy if you have a bunch of different students who like different things. Another way we can use this app is to use it as a source for doing digital reflections. We are always asking the students to reflect on experiences and things they have learned. And so here I have Megan demonstrating what a digital reflection may look like. Hey Megan, I was wondering if you could tell me and everyone else who you think a significant person would be.
Well, actually, we did go to the Holocaust Museum and we met a guy named Serge, and he was a survivor of the Holocaust, and he shared his story and his life during the Holocaust. And I think this is really significant because he made us really aware of what actually happened and the really hard stories that happened during the Holocaust.
For sure. Is there anything you can think of that Serge might have said that would change the way you think about the past as well as how you live your own life now?
He told us one thing that I really remembered, that we can't figure out what's happened, and then we can't just forget about it and let it happen again. So we need to make sure everybody's aware of what's really happened during the Holocaust, so the same thing or maybe similar things doesn't happen again in the future.
Explain Everything also allows you to add photos, and you can do this either through Google Images or images you find on other websites. As well, you can add images that you take yourself. So for a photography class or art class, it can work for students to go around, take photos, and add them to the project and then share them with the rest of the class. As mentioned previously, this app is a great tool for incorporating images. If you wanted to do a one block assignment, you could easily set up a class to go around, take images and or a video for that matter, and incorporate it into this app and then go forth to explain why the images may be good or bad or what was happening in the video, etc. Now, Priyanka and I are going to demonstrate how we could use this app to do something like translating sentences. For instance, if I was to ask Priyanka how to say "I like my dog" in French, Priyanka would say,
J'aime mon chien.
That sounds good to me. Then if I said, Priyanka, can you tell me in French, I went shopping this weekend?
Ce week-end, j'ai magasiné.
That sounds nice. Then I might ask Priyanka to say in French, did you finish your homework? Something every teacher wants to know.
Est-ce que tu as fini les devoirs?
Ooh, I think that's right. We'll give her 2 checks. And then my personal favorite, Mrs. Ewart is magnificent.
Mrs. Ewart est magnifique.
Perfect. 20 out of 20. Thanks, Priyanka.
So right now we're going to evaluate a simple limits question using L'Hopital's rule. L'Hopital's rule states that if you get an answer such as 0 over 0 after plugging in the x value into your limits equation, then you can find the derivatives of the top and the bottom respectively, and you can figure out the limits with using the derivatives by plugging in the x value. So here we have the original equation, which is the limit as x approaches 2 for ln of f of x minus ln of g of x over e to the power of x minus 2 minus 1. So if we plug in our x equals 2 into the equation, we get ln of 4 minus ln of 4 over e to the power of 0 minus 1. This reduces to 0 over 0, which is an answer that is undefined. So now, if we find the derivatives of the top and the bottom, then we can reevaluate to find a real answer. Over here at the top, we have the given values of f of 2, which is 4, g of 2, which is 4, f primed of 2, which is negative 1, and g primed of 2, which is negative 3. So now if we derive the top, we get f primed of x over f of x minus g primed of x over g of x. This is because the derivative of a ln is the derivative over the original function. So the derivative of ln of f of x would be f primed of x over f of x. So now moving on, the derivative of the exponential is the derivative of the exponent multiplied by the original. So the derivative of x minus 2 is just 1, because the derivative of x is 1 and the derivative of negative 2 is 0. So it would be 1 multiplied by the original, e to the power of x minus 2. Now if we plug in our x values, we get f primed of 2 over f of 2 minus g primed of 2 over g of 2 all over e to the power of 2 minus 2. E to the power of 2 minus 2 is e to the power of 0, and anything to the power of 0 is just 1. So we can forget about the e part. Then f primed of 2 was given as negative 1, so we put in negative 1 on top, and then f of 2 was given as 4, so negative 1 over 4 is the first fraction, minus g primed of 2 was negative 3, and g of 2 was given as 4. Negative 1 over 4 minus negative 3 over 4 is 2 over 4, which is 1/2. And there we go. The answer to our limits was 1 over 2.